What if the universe has an expiration date? It's a question that has captivated astronomers, physicists, and philosophers for centuries. The universe, as vast and enduring as it seems, might not last forever. Join me on a journey to the edge of time and space as we explore 5 fascinating theories about how our universe could meet its end. Get ready, because I'll be ranking these theories from least to most probable, culminating in the one scenario that might just be the most likely way it all ends for us. Let's begin with a theory that is perhaps the most chilling in its quiet inevitability: the Big Freeze, also known as heat death. Imagine a universe where stars, those magnificent nuclear furnaces, slowly begin to fade away. One by one, they exhaust their fuel and blink out, leaving behind only cold, dark remnants. Over eons, even these remnants drift further apart, driven by the relentless expansion of the universe. Galaxies, once islands of light and life, become isolated islands in a sea of ever-growing darkness. The universe descends into a state of maximum entropy, where everything is evenly distributed and no usable energy remains. Like a cup of coffee slowly cooling to room temperature, the universe reaches a state of thermodynamic equilibrium. No new stars can form, no new galaxies can arise, and the universe becomes a cold, dark, and desolate place. It's not a sudden or violent end, but a slow, drawn-out fade into oblivion. If the universe continues to expand indefinitely, as observations suggest, then the Big Freeze becomes a very real possibility. In a universe destined for heat death, every spark of life, every burst of starlight, becomes even more precious. But what if the end is not a slow fade, but a sudden, catastrophic event? Let's move on to our next theory. Now let's explore a theory that's quite the opposite of the Big Freeze, the Big Crunch. Instead of expanding forever, what if the universe's expansion eventually slows down, stops, and then reverses? Imagine the cosmic clock winding backward. Galaxies, instead of drifting apart, begin to draw closer together. The space between them shrinks, and their gravitational pull on one another intensifies. Collisions between galaxies become commonplace, leading to spectacular displays of star formation and galactic mergers. But these cosmic fireworks are just a prelude to the main event. As the universe contracts further, the density of matter and energy increases dramatically. Stars are squeezed together, their cores igniting in a final, brilliant burst of energy. Black holes feast on the surrounding matter, growing larger and more powerful. The temperature of the universe skyrockets as everything is compressed into an increasingly smaller space. Eventually, all matter and energy are concentrated into a single, infinitely dense point, a singularity, much like the one from which the universe is thought to have originated in the Big Bang. The Big Crunch is a captivating theory, a cosmic echo of the universe's birth. However, current observations of the universe's expansion don't support the Big Crunch scenario. But what if this accelerating expansion has even more dramatic consequences? Hold on tight as we explore the mind-bending concept of the Big Rip. Chapter 3. The Big Rip, a universe torn asunder. Fasten your seatbelts, folks, because we're about to dive into a theory that's truly mind-boggling: the Big Rip. This isn't just about the universe ending, it's about the very fabric of space and time being torn apart. The Big Rip hinges on the mysterious force known as dark energy, which seems to be driving the accelerating expansion of the universe. But what if this dark energy is even more powerful than we currently understand? In the Big Rip scenario, dark energy doesn't just overcome gravity over vast distances. It becomes the dominant force on every scale. Imagine a universe where the expansion isn't just happening on a cosmic scale, but is also happening within galaxies, within star systems, even within atoms themselves. First, galaxies would be torn apart, their gravitational bonds no longer strong enough to resist the relentless push of dark energy. Then, stars themselves would be ripped apart, their immense gravity no match for the force that's pulling them apart from within. Planets would be stripped from their stars, their orbits becoming unstable as the fabric of space-time around them stretches and tears. And finally, even atoms themselves would be shredded. The forces that bind protons and neutrons together, overwhelmed by the all-consuming power of dark energy. The Big Rip is a chilling vision of the universe's end, a cosmic doomsday where everything, from the largest structures to the smallest particles, is utterly destroyed. But perhaps the most unsettling theories are those that involve forces and phenomena we barely understand. Our next theory takes us to the realm of quantum physics, where the very nature of reality is uncertain, and the end of the universe could be triggered by a quantum event of unimaginable proportions. Prepare to enter the strange world of vacuum decay. Chapter 4. Vacuum Decay, the Quantum Apocalypse. Now, brace yourselves, because we're about to delve into a theory that's as perplexing as it is terrifying. Vacuum decay. This one goes beyond the realm of astrophysics and takes us deep into the strange and uncertain world of quantum mechanics. In the quantum world, things aren't always as they seem. Empty space, what physicists call a vacuum, isn't actually empty. It's a seething cauldron of quantum fluctuations, filled with virtual particles popping in and out of existence. According to some theories, our universe might not be in its lowest possible energy state, what physicists call a true vacuum. Instead, it might be in a false vacuum, a state that's metastable, like a house of cards, seemingly stable, but susceptible to collapse if disturbed. Now, imagine a quantum fluctuation, a random event in the quantum foam that creates a bubble of true vacuum within our false vacuum universe. This bubble, governed by different laws of physics, would expand at the speed of light, devouring everything in its path. Here's the truly terrifying part. We wouldn't see it coming. Light itself can't travel ahead of the bubble to warn us, so the destruction would be instantaneous. One moment, we'd be going about our lives, and the next, everything we know, everything in the universe, would cease to exist. Vacuum decay is a theory that truly pushes the boundaries of our understanding. But what if the end of our universe isn't the end of everything? What if instead, it's just the beginning of something new and unimaginably vast? Our final theory takes us on a journey beyond the boundaries of our universe and into the realm of the multiverse. Chapter 5. The Multiverse Collision, a New Beginning? For our final theory, we're going to journey beyond the boundaries of our own universe and into the mind-boggling realm of the multiverse. The idea that our universe is just one of many coexisting in a higher dimensional space might sound like science fiction, but it's a concept that's taken seriously by many physicists. Imagine a vast cosmic sea filled with countless bubbles, each one a universe unto itself. These universes could have different laws of physics, different fundamental constants, even different dimensions of space and time. Now imagine that these universes are not entirely isolated. What if, from time to time, they collide? These collisions could be cataclysmic, reshaping the very fabric of the universes involved. In the case of our own universe, a collision with another universe could manifest in a number of ways. We might observe strange gravitational anomalies, distortions in the cosmic microwave background radiation, or even the sudden appearance of new matter and energy. The consequences of such a collision are difficult to predict, but they could range from the relatively benign to the utterly catastrophic. Our universe might be pushed into a new phase of existence, its laws of physics altered in fundamental ways. Or it could be completely destroyed, consumed by the colliding universe. The multiverse theory is a tantalizing one, offering a glimpse into a reality far grander and more complex than we ever imagined. It suggests that the end of our universe might not be the end of everything, but simply a transition to a new chapter in the grand cosmic story. The cosmic mystery continues. So, there you have it, 5 mind-blowing theories about how our universe might meet its end. Which of these theories do you find the most fascinating? Let me know in the comments below. I'm eager to hear your thoughts and continue this cosmic conversation. If you enjoyed this journey to the edge of time and space, don't forget to hit that subscribe button and ring the bell for more explorations of the universe and its mysteries. Until next time, keep looking up, keep asking questions, and keep your sense of wonder alive.